Dynamics track, and this is a dynamics part. I've got it kind of propped up there on the end, so if I give it a push, it slows down, stops, comes back down. And this is an accelerometer. So it tells you if it's accelerating. Right now it tells you it's not accelerating. But if I give it a little push, notice how the green lights came on right when I was pushing it, and when I stopped pushing it, the red lights coming on to show that it was accelerating down the track. So it's very sensitive. It'll always show you what direction it's accelerating in. Green means that way, red means that way. My question for you is this. I want you to tell me what the lights are going to look like. From the time I push it, to the instant I stop pushing it, to its passage up the track, to the point where it stops, to the point where it goes down the track, to the point where I catch it again. Okay? So from the push, all the way up and back until I stop it. What do the lights look like, do you think? I see one hand. Two hands. All right, Aiden, what do you think?
It's going to be green when you push it, and then red. I don't really know how it works, but it won't be accelerating as it goes up. And it'll stop, it'll be accelerating back down.
If you say it's not accelerating, you're saying that whatever speed I got it up to, it'll stay at that speed.
Pretty, yeah.
If it's slowing down, it's accelerating, but it's a negative
yeah.
acceleration.
Negative acceleration.
Okay, so what are the lights going to look like?
I don't really know how that works.
Green means it's not necessarily moving that direction, but it's accelerating that direction. Red means
green,
it's accelerating.
Red.
What about when it gets up to its highest point and it stops at that point?
Yeah.
Red, green, or none? So you're saying when it, at the moment that it's motionless, it's accelerating. Okay? No? Okay. What about when it's going back down the track? What about when I stop it? Okay, so here's what he said. He was pretty quiet about it. He said, when I push it up the track, it's going to be green until the moment when I release it. Then it's going to be red. Then when it stops, all the lights go out. And then it's red all the way back down until when I catch it, and then it'll be green. Oh, okay. Confident this time. Is he?
When it's going, like, wait, is green for it's accelerating or when it's
Green
accelerating
means
going?
it's accelerating this direction. Okay, you're wrong, but you're almost right. There's just one part that's wrong. Kevin?
It's not going to be, at the very end, it's not going to be green accelerating, or the light's not going to be green.
No, that wasn't it. Jared?
It's going to be green when it's going back down. 'Cause it's
Aiden?
It's going to be green at the top.
No.
No, it's going to be red.
Well, okay, we'll take one more. Elliot?
It's going to be red at the very top.
When it's stopped?
Yeah.
Okay. He's right. So I want you to watch. Lindsay, you have a question?
Yeah, can you say the different segments again when you push it, when it
Yeah.
stops?
When I push it, well, let's watch it first, and then we'll go through it, okay? So his prediction is green when I'm pushing it, red as soon as I let go, red all the way up, red even at the very top, red all the way back down until I touch it, green. Is that what you're saying? It was. I'll give it a little bit more of a push this time. Red, green. For just an instant, because I stopped it pretty quickly. So this is really, this is a hard one. It's a hard one to interpret and to understand. Acceleration is not easy. So when I'm pushing it, I'm taking it from, let's put some numbers to it. Let's say that I get it up to 2 meters per second. So I push it, it's not moving now, I get it up to 2 meters per second by accelerating it that way. As soon as I let it go though, gravity is accelerating it this way. And let's say that gravity gives it an acceleration of -1 meter per second squared. The negative's there because it's slowing it down rather than speeding it up. So after a second, how fast will it be going? got it up to 2 meters per second. 1 meter per second. Okay, how about after another second? 0. Okay, we'll take it down to 0. How about after another second? Negative 1 meter per second. Your problem is you're looking at it as up and down, as two different motions. Make sure you understand this. The motion hasn't changed. Don't look at it as going up and down. Look at it as smoothly passing from 2 meters per second to negative 2 meters per second. Every second, taking off another meter per second. And yes, if you do that, you have to sweep through 0. And when you sweep through 0, at that point that you sweep through, it stops. Elliot?